All right, so average rate of change today is what we're talking about. And just a second ago on the bell work, we did slope, which is the exact same thing as the average rate of change. The formula looks a little bit different for the average rate of change, but if we talk about what it's really looking like here, this is the function of B and the function of A. So if A is on your x-axis, your function of A would be your y-axis. So these really still are just your y values. So you could still do y2 minus y1. And then B and A here are your x values. So that would still just be x2 minus x1. So when I write the formula down for you guys, I still use the slope formula when we're doing average rate of change, because you already know the slope formula. So why would I want to change something that you already know to something you don't know, right? So we're still going to write it down as the formula of this. But the average rate of change of a function over an interval is the amount of change y divided by the length of the interval. And the length of the interval is x. Okay, so the changes of y's over the changes of x. So let's take a look at this and let's see if we can decide what it wants us to do here. So we're going to find the average rate of change over the interval -3 to 0. Now I want to talk about just for a minute what interval means, because we've talked about interval for like all of this chapter. And you guys remember that when we talk about an interval, we're looking at the x-axis, right? So this says look at the x-axis from -3 to 0. Do you guys agree with me? That would be the interval? Yeah. So I want to make note right here for just a minute. This is an x value and this is a x value. Do you guys agree with me on that? So when we're talking about intervals, make sure that we remember that we're talking about x values. So in order to do the slope formula, I actually need ordered pairs. I need an x and a y, and then I need a second x and a y. So if I know my x value is -3, could I figure out my y value right there? What's that ordered pair on the graph? -3, 1. Good. So really what I just did was I used my interval value to find my ordered pair. Did you see how I did that? So do the same thing at x equals 0. Right here at x equals 0, what's the ordered pair that's there on my graph? 0, 2. Nice job. Okay. Now that I have my two ordered pairs, guess what I can do? Plug them into the formula, right? So again, I'm just going to rewrite the slope formula for you, even though when we do average rate of change, they usually write the formula a little bit different in function notation. I'm still just going to use the slope formula because you remember what it looks like. So let's go and plug things in. Is it okay if I call this my second ordered pair and this my first ordered pair? So I'm going to do y in my second ordered pair, which is 2, minus y in my first ordered pair, which is 1. And then over the top of x in my second ordered pair, which is 0, minus x in my first ordered pair, which is a -3. Does anybody have questions where I got that from to sub it in? We're good? Okay, simplify on the top then. What's 2 minus 1? 1. And a -3 would be 3. So guess what my average rate of change is? It's 1/3. Now I want to point out something to you right here, because we did it by algebra, but look at this. If I would have counted my rise, which is 1, over my run, guess what I would have got? 1/3, up 1/3. Do you see how the average rate of change is really the same as the slope? But I want to bring up a point here when I do this, is just so that you notice, if we found the average rate of change between those 2 points, it would be that straight line that went between those 2 points, which it almost looks like it's part of the curve right there. But the curve actually has parts that would be above that line. Does that make sense? We're actually finding the average slope for that part of the curve. Okay? All right, we're doing again over here. Our interval is from 0 to 2. So our x value of 0, our x value of 2. So right here is the interval we're looking at. we're going to use these as our x values, and we're going to find our ordered pairs. Okay? So at 0, what's my ordered pair on my graph? 0, 1. Nice. And at 2, what's the ordered pair on the graph? 2, 4. Okay. Now that I have those ordered pairs, I can plug them into my rate of change formula, which is the same as the slope formula. So you do 4 minus 1, because you do your y minus your y, over your x minus your x. Is everybody okay with where I got those numbers from? All right, let's simplify then. What's 4 minus 1 on the top? Yeah, it is 3 over 2. Okay, now another point to be made, if we were to just count our slope, 1, 2, 3, and over 2, would it be the same thing? So if they give you a nice graph like this and you have these perfect ordered pairs, you could count your slope, your rise over your run, for the average rate of change. The reason I'm going to keep showing it to you though is because not always do they give us a nice graph to look at, and we have to figure out how to do it other ways. Does that make sense? Okay, and then just another point again to make, that the average rate of change would be that straight line between there and there. Do you see how it doesn't follow the curve exactly? Because some of the change is going faster than that, some of it is going slower than that. Okay? All right. This time it says calculate the average rate of change over the given interval. Now you guys could totally graph this, but why would we want to, right? If we don't have to graph, we really don't want to. Now I want to remind you that this is an interval. So those are both x values. Do you guys agree with me on that? So if I have an x value of -2 and I wanted to find out its y value, what would I do with -2? Can I plug it into the function in place of the x? Right? Because it's an x value, right? So that's what I'm going to do. I'm going to come and I'm going to put it into my function. So I'll have 4 times -2 squared minus 6. So that would be putting in -2, and I'm going to see what I get out. I'm making an ordered pair from my function without graphing it. Does that make sense to everybody what I'm doing? Okay. So order of operations says exponents first. So -2 squared would be -2 times -2, which is +4. 4 times 4 is 16, and 16 minus 6 is 10. So when you put -2 in, you get 10 out. All right, I got to find another ordered pair. What am I going to substitute in this time? 8. So I'm going to do 4 times 8 squared minus 6. This is going to be quite a bit bigger. If you don't have a calculator yet, you're going to want to grab one. You're going to square 8, which is 64. Do 64 times 4, which is 256. And 256 minus 6 is 250. So when I put in 8, I got out 250. Okay? Now that I have 2 ordered pairs, I'm going to use my slope formula. Okay? Does that make sense to everybody what I'm doing here? All right. I don't care which one you start with. Just remember, if you start with the top one, you start with this top one on the top and the bottom of the formula. I like to start with the bottom one. So I'm going to go 250 minus 10, and then 8 minus a -2, because it's y is on tops and then x is on bottom. If you did it in the opposite order, it would still work out to the exact same answer, okay? So on the top I have 250 minus 10, which is 240. On the bottom I have 8 minus a -2, which is really 8 plus 2, which would be 10. And 240 divided by 10 is 24. So my average rate of change, meaning if I were to graph this between these 2 points on my x-axis, I would have gone up 24 and over 1, right? Because that would have been my slope, 24 over 1, for the slope of the line for the average rate of change on that curve. Does that make sense to everybody what we just found there? All right, one more time then. This time we're not looking at an equation and we're not looking at a graph. This time we're looking at a table of values. So again, tell me what these interval values are. They're both x's, right? It tells us where to look on our x-axis for our interval. So I'm going to go and look at my table and I'm going to see if my x values are over there. Do I have an x value of 3? I do. I'm going to circle that ordered pair because that's one of the ordered pairs I'm going to use in my slope. Do I have an x value of 7? I do. So here's my second ordered pair I'm going to use in my slope. Now what are we going to do? We're going to put it through the slope formula or the average rate of change formula, okay? So y minus y, 26 minus 10, over x minus x. So 7 minus 3. Questions on how I got that formula? Okay, on the top then I have 16 because 26 minus 10 is 16. On the bottom I have 4. And 16 divided by 4 is 4. So my average rate of change would be a slope of 4, up 4 over 1 between those 2 points on my x-axis. Questions on how I did that? Awesome.